So this is 5.1 homework on inductive and deductive reasoning. And then number 1, we want to determine whether the reasoning is an example of inductive or deductive reasoning. So just to remind you, the idea of inductive reasoning, typically we go from some specific cases and apply them to the general case. And deductive reasoning, we do the opposite. We take some sort of general principle and then apply it to a specific case. So in part A, it says Carrie's first 3 children were boys. If she had another child, it would be a boy. So the idea is that these are specific cases, and we're applying it to the general case, every next child. And so this is an example of inductive reasoning. One way to spot inductive reasoning is oftentimes the conclusion can be false. So we all know that Carrie's next child could also be a girl instead of a boy. So this says Bob has 2 children exactly 3 years apart in age. If the youngest child is 2, then the other child is 5. And so this is an example of deductive reasoning, because we're going from, in a sense, a general principle of that Bob has these 2 children, and they're exactly 3 years apart. And so we know the youngest child is 2, so we can conclude that the oldest child is 3 more years added to 2, so 5 years old. Part C, the stock market has gone up on average for the last 5 years. The stock market will go up this year too. So again, these are specific examples for each of the 5 years here. The stock market has gone up on average, so therefore our conclusion is it will go up this year too, and we know that could be false. So the idea is we're going from specific to the general, and so this is an example of inductive reasoning. I guess we just spelled reasoning here and there. Alright, then part D, all people are mortal. I am a person, therefore I am mortal. This is an example of deductive reasoning. All people are mortal, so we're assuming this is true. And because this assumption is our sort of general principle, then we're applying it to myself. Since I am a person, therefore I am mortal. And finally, part E, all my siblings hate pickles, therefore I will hate pickles. So this is actually an example of inductive reasoning. Again, just because everybody in your family hates something does not mean you're going to hate something too. And so again, you're going from these specific cases, your siblings, and you're concluding it for a general case being you. So in number 2, we use inductive reasoning to guess at the next term of the sequence, and then use deductive reasoning, right, to figure out, to deduce what the sequence is, an arithmetic sequence or geometric sequence. So I look at the first term, so I have 6, 9, 12, 15, and 18. And what I notice is that if I add 3 to 9, add 3 to 6, I get 9, add 3 to 9, I get 12, plus 3 is 15, plus 3 is 18. Right, so the next term, right, I'm just adding 3. So the next term would be 21. Right, and I classify the sequence as either arithmetic or geometric. And so this is an example of inductive reasoning. I look for a pattern and I see this pattern of adding 3, so it's 21. It's sort of the specific cases, and I go towards the general. And then I classify it. Since I'm adding 3, I know that this is an arithmetic sequence. The difference between an arithmetic sequence and a geometric sequence is that in an arithmetic sequence I'm adding, whereas in a geometric sequence I'm multiplying. So in this one, I go to 3 to 12. Now, if it's arithmetic, I would add, 9? But if I add 9 to 12, I do not get 48, right? 12 plus 9 is 21. But it looks like I'm multiplying by 4, so 3 times 4 is 12, yeah. 12 times 4 is 48, yeah. To check the next one, I might need my calculator. So on this one, if I take 48 times 4, right, do I get 192? Yep. Multiply it by 4. Do I get 768? Yep. So the next one will be multiplied by 4. Right, so this one, multiply by 4. So the next one would be 3072. And because I'm multiplying, I can use my deductive reasoning to classify this as a geometric sequence. And then this last one here, I have 7, 14, 28, 56, and 112. So I can check if it's arithmetic if I add. So if I add 7, I get 14. If I add 7 to that, I do not get 28. I get 21, so I know I'm not adding. If I multiply here, I multiply by 2. That's 14. By 2 is 28. By 2 is 56. By 2 is 112. And then by 2 is 224. And so I'm multiplying by 4. So I just multiply. Multiply by 4. And so this is a geometric sequence. And so the point of these problems is to try to help identify when you're using inductive versus deductive reasoning, and basically kind of searching for patterns and then figuring out the next term. We do this again in the number 3. This one's a little bit harder. It says the following sequences are not arithmetic or geometric, but you can still use inductive reasoning to determine the next term. You should use the method of successive differences to figure out the next term in the sequence. Right? So notice you can easily see that most of these sequences are not arithmetic or geometric by simply saying, okay, well, if this is arithmetic, then I'd be adding 8. Well, if I add 8 to 14, yeah, I get 22. But if I add 8 to 22, I don't get 32. Same with the multiplication. And the idea behind this is to actually make this web. So you take this method of successive differences, so 22 minus 14, and you can use your calculator if you want, but this one is 8. 32 minus 22 is 10. And then 44 minus 32 is 12. So I'm just subtracting the two terms. And then 10 minus 8 is 2. 12 minus 10 is also 2. Right, and then I try to recreate this web here. Alright, so to recreate the web, the idea is down here I still have a 2 because everything on this line will be 2. And I ask myself the question, what number goes here? When I subtract it from 12, I get 2, and that's obviously 14. Right? And so then again, I recreate the web here, and I ask myself the question, what number goes here? When I subtract it from 14, I get, I subtract it from 44, I get 14. And so that one, right, one way to do this is just kind of guess and check, right? So if it was like 50, I get 6. Right, so that's not right. 56 or 54 would give me minus 44 would give me 10, and so this one should be then 58, because 58 minus 44 is 14. Another way to realize what number this is, you notice that 12 plus 2 is 14, 44 plus 14 is then 58. Right, so the next term in the sequence is 58. All right, let's look at the next one and do the same thing. So again, I know it's not geometric or arithmetic because you can, take the differences here, like 15. This would be plus 10, and plus 10 is not 37, right? And this would be times 3, and times 3 is not 37. So it's neither geometric nor arithmetic. But I can take the differences. So if I take the difference here, I get 10. Right, if I take the difference here, right? So 37 minus 15, this is going to be 22. And then if I take the difference here, 77 minus 37, this is going to be 40. And then if I take the difference here, now I'm going to start using my calculator. So I take out my calculator, I take 141 minus 77, and I get back 64. And then I do it again. 22 minus 10, well, this is 12. 40 minus 22, well, that's 18. 64 minus 40, that's 40 there, is 24. And then I do it again. So 18 minus 12 is 6. 24 minus 18 is 6. And so now I realize that this line, everything should be 6's. And so I recreate the web on this side. I have a 6 here. And I go back up. And I ask myself the question, what number goes here? And I take away 24. I get 6. So that's 30. I could also just take 6 plus 24, and that's 30. Over here, what number, when I subtract 64 from it, I get 30, and so that's 94. And then over here, right, this is attached to the 141. Right, what number goes here when you take away 141? I get 94. So I can do some guess and checking, or I can just realize I take 141, I add 94 to it, and that's going to give me the appropriate number of 235. So that's my next number in my sequence. All right, finally, this last one, part C. So here I take, 20 minus 6, which is a 14. 50 minus 20, which is 30. 102 minus 50, which is a 52. 182 minus 102, which is 80. And finally, 296 minus 182, that one I'll use my calculator, so 296 minus 182. And I get 114. I do the next line, 30 minus 14 is 16. 52 minus 30 is a 22. 80 minus 52 is a 28. And 114 minus 80 is 34. Then I keep going. So 22 minus 16 is an 8. Oops, that's a mistake. So 22 minus 16 is actually a 6. There we go. 28 minus 22 is a 6. 34 minus 28 is a 6. Good. So again, they're going to be all 6s. And so I can take a different color here. And I can recreate this web. So I have a 6 here. Then what number goes here? Well, this is going to be then 40, because 40 minus 34 is 6. And then what number goes here? Well, this is going to be 154, because 154 minus 114 is 40. And then what number goes here? Well, I got to figure out some number. When I subtract 296, I get 154. So one way of answering that, again, is just to take 154 plus 296. And that will give me, again, the appropriate number of 450. Right? That's the next term in my sequence. All right, so and then on this last one here, the challenge problem, it says that all the sequences we have done so far have formulas that will give us each term. For example, if you look at 2a, you have 6, 9, 12, 15, and 18. The formula for this is actually given by 6 plus 3n. This means that the 100th term in the sequence will be given by 6 plus 3 times 100. Right, the stat button on your calculator can be used to find these formulas, try and figure it out. Okay, so there are actually lots of ways to do this. So let me just go through a couple of real quick examples. Right, this formula here, right, f of n. Right, when n is 1, you get out 6. When n is 2, you get out 9. When n is 3, you get out 12. Right, so what you're doing is you're taking 6 and you're adding 3, right, n times. Now you have to be careful. Right, if you look right down here, right, what you're doing here is this is for the 0 term, right, if you start this at 0 and so on. So I guess we need to make this clear that we're going to call this the 0 term, this the first term, this the second term, this the third term, this the fourth term, and then this is the appropriate formula. For this one, we're multiplying by 4. And so the idea on this one is that f of n, the formula, would be, well, we start at 3, and then we're multiplying by 4 n times. Right? So if it's 0, it's 4 to the 0, which is just 1. If it's 1, we're multiplying by 1, 4. If it's 2, we multiply by 4 times 4, so 4 squared. And if it's 3, we multiply by 4 times 4 times 4, 4 cubed. And we can even do this one here on part C. We'd say f of n is equal to what? We start at 7. Right? And we're not adding, we're multiplying again by 4, so it'd be times 4 to the n. Right? Remember, though, that this is the 0 term, the first term, the second term, third term, the fourth term, and so on, and then this formula will work. On the back page, you might not know this, but these are actually special sequences, right? The idea is that this can be modeled by a quadratic formula. This can be modeled by actually a cubic formula, and same with this one. So to find formulas for these, just for fun, what we can do with our calculator, you can hit the stat button, and you can hit enter. But this is where we put our list, so you can actually say, the 0 term, the first term, the second term, and the third term. All right, for the 0 term, you can put in 14. For the second term, you put 22nd. 22, and then 32, right, then 44. Right. And if you know that a quadratic function is used to model this, you can simply hit stat, go over to calculate, and here we use linear and exponential reg, but down here you see quadratic reg, and you can hit enter, and out will pop the formula for this formula, so for this sequence. And so what you get is a times x squared, so use x squared because a is 1, plus 7 times x plus 14, and that's a square there. Oh, and I shouldn't use x, right? I should use the appropriate letter, which we're using n here. So let me use n. So n squared plus 7n. Okay, I can do the same thing for part B. And so if you go back to stat, you hit enter, right? I can put in 5 for my 0 term, 15 in for my first term, 37 in for my third term, 77 in for my fourth term. And on this one I have a fourth term here, right? So 141, so 141. And this time it turns out it's a cubic. You actually count the rows. If this is constant, it's linear. If this is constant, it's quadratic. If this is constant, it turns out to be a cubic. So I hit enter and then stat. Go over to calculate, and there's cubic reg. Right? This will find a cubic formula that fits my data. And so I hit enter, and out pops my answer. So on this one, f of n is equal to, again, a is 1, so I get x cubed, which keep making that same mistake, right? So this should be an n. So n cubed plus 3n squared plus 6n plus a 5. All right, so your calculator can be useful to find these formulas. And you can check this, if you plug in 2, you should get out 15. If you plug in 37, I'm sorry. Right, if you plug in it's 0 term, first term, second term, third term, fourth term. So if you plug in 2, you should get out 37, 3, 77, 4, 141. And this formula will actually do that for you. So if you want to find the 100th term, f of 100, right, you simply compute the value 100 cubed plus 3 times 100 squared plus 6 times 100 plus a 5. And you can do this on your calculator, right? 100 raised to the 3 plus 3 times 100 squared plus 6 times 100, and then plus 5, and hit enter, and out pops this huge term, right? So 1,030,605. Right? You can do the same for part C, but it's actually the same process, so I'm not going to do it.